I'm going to introduce Daniel Beutel. He is a fantastic guy I've been working with now for a number of years, I guess. He is one of the creators of the Flower Framework. He is also a visiting researcher at the University of Cambridge. And he also is one of the founders of a really powerful startup based in Germany, Hamburg, called EdUp. And today he is going to be presenting what he calls the flower state of the union. He's going to tell us about, where is this tool heading? How can it both assist the progress of federated learning in terms of research, its adoption in terms of products, and then that sort of gray area in between the sort of like federated learning ops that are so important set of topics for us to move the whole area forward. So with that introduction, I'll hand over to Daniel, and thank you again, Demetrius, for your talk. Take it away, Daniel.
Yeah, thank you very much for the introduction, and thanks for this fantastic keynote. I think it was very great, and it shows that there are a lot of open questions to explore. And I will now continue to give an update on the Flower platform, which is one tool that you could use to build and explore such approaches. I would like to start with a little bit of background motivation. To start off, let's look at where most machine learning projects are today. Most of the time when we talk about machine learning, nowadays it is basically centralized machine learning. And we've seen sort of the differences between centralized machine learning and federated machine learning in the previous talk. But I would like to start off with a very high level introduction. So usually what we have in a centralized machine learning system is a system that consists of data, and this data usually is being collected from basically distributed devices. Those distributed devices, they can be either mobile apps running on smartphones, or they can be, the data can originate from sensors that are connected to distributed edge devices, like some IoT device. And then if we want to act on that data, if we want to train a machine learning model on that data, what we have to do today is collect all of this data in a central place, often in the cloud, and then we train a model on that data, which is indicated by the circle on the very top. Now this comes with a bunch of challenges. First of all, in some cases, it's not possible at all to collect the data in a central place. So they can be either regulatory hurdles or technical hurdles if the data volume is too large that prevents us from collecting the data in a central place. And then federated learning is an attempt to solve that, to overcome these hurdles and to make to bring machine learning in more domains and to make it accessible for more use cases. So in federated machine learning, we basically just turn this around. So instead of sending the data to a central place and collecting all of the data in the cloud, we send the model to the data. So we send the model to the data, we train the model on the local data, which is a subset of the entire data set. And then we send these refined models back to the cloud. We do have multiple of these refined models, and then we aggregate these models to get a global model that then hopefully contains the learnings of all of these individual local data partitions. And to simplify this even more, what we want to do is we don't want to send the data to the model, but we want to send the model to the data. And the opportunity here and also the challenge are massive. What we can see is that over the last 2 decades, we had Web 2.0, then we had the mobile revolution, which created, every time there was an entire wave of new data. And over the next decade, we'll see a proliferation of additional kinds of edge devices like consumer drones. We'll see consumer robotics like the Roomba. We see smart manufacturing. We will see smart vehicles. We see micromobility like e-scooters. But we also see smart home devices, smart watches. We see certain verticals like agriculture move towards smarter devices. And this proliferation of intelligent edge devices is a massive opportunity. So we want to use machine learning on these devices. And in many cases, we cannot collect all of the data. So we have to use approaches like federated learning or fleet learning or similar approaches, more hybrid approaches to make these devices intelligent. But it's also a challenge, obviously, because all of these devices, they are very different. The compute capabilities are different. The connectivity that they offer is different. And also the software stack that is running on these devices is very different. So it's both an opportunity and a challenge. And another challenge that we see is basically we have a ton of existing machine learning projects. And these projects, a lot of effort went into building these projects. And we depict it here in a funny way. But it's actually a lot of effort has gone into developing these projects, has gone into refining the projects, has gone into developing everything around it. And often some tools that we look at in the federated learning space, they require you to basically throw all of that effort away and require you to rewrite most of what you have had before from scratch. So that's not an ideal situation to be in. So an ideal toolkit would offer compatibility with all the hard work that people already put into their projects. And that's basically the background that we saw and that we used to develop Flower, which we call the friendly federated learning framework. Flower basically is one offering to build such workloads across a fleet of devices. And we call it the friendly federated learning framework because it's compatible with existing toolkits, with existing projects. So it allows you to build workloads that use, for example, TensorFlow on the client. It allows you to build workloads that also use PyTorch or something else on the client. And it allows you to really customize what is happening on the client to that particular client. So what is happening on the client will be very different depending on whether you are on a smartphone or you are on a powerful server or even a cluster of servers, or whether you are on a embedded device, for example, something like a smart home device. So the capabilities that Flower offers, the key differentiators that we see when we compare it to some other offerings are on the one hand, the compositionality, which means we are compatible with a lot of different machine learning frameworks, with different platforms, even with different programming languages. But also we try to package up this all of this flexibility that the framework offers into a very nice and very usable framework. So usability is another key aspect that we take a lot of care about. Scalability is another thing that we intentionally designed into the framework. We tested the framework, for example, with workloads comprised of 10,000 really connected devices, 1,000 of them training concurrently, exchanging 90 gigabytes of data each round, which is compared to some other basically volumes, some other scales that we see in some federated learning papers, which is, I would say, massive scale. And then we also want to offer a way to basically unify your solutions across different kinds of approaches. So we have approaches like federated learning, but then there's also related approaches like federated analytics, domain adaptation, fine-tuning, also fleet learning, which are all sort of different, but also sort of related. And they all require pretty much similar infrastructure in order to build them. And Flower wants to offer one solution that allows you to build all these kinds of workloads. So we have a talk on a code tutorial that showcases usability. And we have another talk coming up called Scaling Up Federated Learning with Flower that goes into more detail about these scalability considerations. So how do we implement this? What's under the hood? How does this look like from a framework perspective? How do we achieve these goals in the Flower framework? Flower, as I mentioned before, has a pretty modular architecture, and we start off at the top right corner, where we basically have existing machine learning projects. So an existing machine learning project, it usually consists of a training pipeline implemented in PyTorch or implemented in TensorFlow, and some kind of local data. And then we want to federate this, and that's where the Flower framework comes in. The Flower framework gives you good default options to federate these existing pipelines. And for a very simple case, you can just use the server and use the client SDK as it is to federate an existing project. But then you can go into more detail once you get familiar with it, once you want to build a more sophisticated setup. And you can use what we call strategies on the server side. Strategies basically encapsulate the server-side components of existing federated learning algorithms. So there's something like fed averaging or Q-fed averaging or federated. And the server-side components, they are offered by the framework either as built-in strategies, or you can get strategies, for example, from GitHub implemented by someone else, and you reuse them across different tasks. And I think that's a pretty powerful concept, because we have these implemented, these encapsulated algorithms, and we can reuse them across different tasks, such as classification or other tasks. And then there's one additional capability that I would like to mention, which is basically integrating with the Flower protocol itself. So we offer a high-level SDK on the client side. Right now, we do have a Python high-level SDK, but we also have a Java SDK built for Android, which is currently being worked on, and there's a pull request about it open. But if you really have a very particular interest, very particular needs, and you want to use a language that is not supported out of the box yet, for example, you want to build a high-performance C++ client and use it together with libtorch, for example, then you can directly implement the Flower protocol, basically establish a connection to the server, handle the events that are coming from the server, and return the appropriate events to the server, and then have a highly customized SDK that has a lot more control over how connections are getting established, how events are getting handled, as compared to the SDKs that we offer in the core framework. So around the Flower core framework, we've seen how the Flower core framework is structured. We've seen the different components. What is happening now is that around the Flower core framework, there's an ecosystem developing. And the ecosystem basically builds on top of this core framework. And what the ecosystem offers you is, for example, usage examples. Usage examples basically show you what you can do with the framework, how you can implement particular approaches. And you can just clone these examples and start to modify them and use it as basically the groundwork to build your own systems. Baselines is another interesting development that just started off. We'll see a bit more about baselines in a talk later today. And baselines basically contains a lot of existing baselines that we use, for example, in papers about federated learning, to compare different approaches, to compare different strategies, and see how they perform on certain data sets. I already mentioned strategies, for example. There's additional client SDKs that are being developed. And one area that I find particularly interesting are integrations with existing tooling. So we'll see a little bit about SpeechBrain later today. And we have a whole bunch of other integrations with other toolkits planned and on the roadmap. So with that, I would like to announce Flower 0.16, which is the latest release of Flower and is available on PyPI for download as of this morning. Flower 0.16 contains a lot of changes, a lot of important changes that lay the groundwork also for future development, but also give you as a developer new capabilities. Let me highlight a few of these. We have some new strategies integrated, for example, an abstract fedopt strategy and a strategy based on that called federated. We have Python 3.9 compatibility. We have new examples and documentation covering MXNet. And two changes are very important in the core framework and constitute basically a medium refactoring in the core framework, which is custom metrics in strategies and the serialization agnostic server. So that's serialization agnostic server basically means that we can serialize the parameters that are coming from models on the client side in any way we would like to. So it's not just compatible with, for example, NumPy arrays as we've been in the past, but it's also compatible with completely different ways of serializing weights. And then these weights can be sent to the server. The server can handle these serialized weights, even though it might not even know how to deserialize them. And then strategies can be implemented to basically deserialize these weights, do something on them, aggregate weights, for example, and return them in a serialized format again back to the server. So that's an important building block in making the server as task agnostic as possible, so that we can in the future build additional client SDKs on top of that. And the Android SDK, which is currently being worked on, is one example for that. So Flower 0.16, Flower 0.15 was basically an alpha version for Flower 0.16. Because we finished some major refactorings, we decided to announce that we will now move Flower into beta status. And we all know, since Gmail got their beta status, the requirements for calling something a beta version are quite high. So we've thought about it for quite a while, but we've seen so many projects being built on Flower. We see the stability that Flower offers, and we think it's appropriate to now move Flower into beta status. Obviously, we're not stopping there. There are quite a bunch of next steps that we have planned. We've planned, on the one hand, additional core features, but then on the other hand, additional integrations that we would like to see. For the core feature side, I think two of the most highly requested features are, on the one hand, secure aggregation and differential privacy. Secure aggregation and differential privacy are high on our list of priorities and are something that will definitely be worked on over the summer. And we have additional people joining the project who will only work on these two topics. So we very much look forward to that. Another feature that will be important for improving client selection is the client-server handshake, where we exchange metadata about the clients with the server, and the server can then make better sampling decisions based on this metadata. Memory efficiency is a big one. So the first steps that we've taken with the Flower framework were more focused on really building a system that allows for really heterogeneous workloads that run across servers, but also edge devices, and that communicate over the network. And now a next step will be to make the server more memory efficient and enable simulations on the server side. And we'll have a talk about that later today. Then another feature in the works is custom server loops. So right now you can start a server with the start server function, but we would like to offer more flexibility there and enable you to implement custom server loops. And then a big one and one that's obviously very important is documentation improvements. On the integration side, we would like to see integrations with TensorBoard and MLflow. We would like to see documented JAX examples and libtorch and TensorFlow Lite examples. Strictly speaking, this is already possible today. It's just something that we haven't documented on how to do it yet. But there is compatibility with JAX, with libtorch, with TensorFlow Lite. Flower, basically, because of its design, is forward compatible also with new developments. But we want to provide a good onboarding experience and a guide on how to do that if you don't want to figure it out yourself. SpeechBrain, I mentioned that one before. There will be additional client SDKs, as I mentioned, the Android SDKs in the works, and then additional examples and strategies that are part of the ecosystem. I mentioned there are going to be a few additional talks about these topics. If you're interested in one of these particular topics, check out the schedule. So really the larger vision behind Flower is to build one toolkit that allows you to experiment with workloads on your developer machine, on a simple laptop, develop these workloads, do some prototyping on the laptop, and then move these workloads through different stages towards production. And the different stages that we often see are simulation, and actually two kinds of simulation. One kind of simulation is really large-scale simulation on a cluster of powerful servers, where we want to simulate convergence properties, where we want to simulate the workload with a very large number of clients, and where we want to see if the machine learning model, if the training still converges as we think it should. And then another type of simulation is simulation on the actual devices that the final model and the final workload will run on. For example, think about a cluster of Raspberry Pi devices or a cluster of smartphones. And once we did evaluation in these two scenarios on actual devices and on a large cluster of machines with a large number of clients, we then want to move this workload into production. And moving into production is particularly interesting if we simulate on edge devices. Sometimes, depending on the kind of device and depending on the kind of environment that we have on the device, we actually need to switch programming languages. So we might start off with a prototyping phase that is being built in Python, and then we might need to switch programming languages, for example, to C++ for higher performance on these kinds of edge devices. Flower wants to offer one solution that allows us to move from these research kinds of environments to more production-like environments. Maybe as a humorous note, I think it's important to realize that there's a massive opportunity ahead of us. We've seen what kind of new devices are being developed and are being deployed in the real world, and we want to make these devices intelligent. And now it's possible, and now it's actually with Flower, it has become easy to build such systems. So it's quite easy to build a sophisticated federated learning system without being a distributed systems engineer with decades of experience. So with that, I would like to invite everyone to get involved with Flower. There are many ways to do this. One way is to join the community. For example, join us in the Slack channel, open GitHub issues if you have particular questions, join GitHub discussions where we just recently started to discuss new features and answer questions around the Flower framework and how to use it, or just simply send us an email or ping us on Twitter. There are also a lot of ways to contribute apart from core framework contributions. For example, the documentation is something that we're working on and that can use a helping hand. You can develop new examples that we can either merge into the main Flower repository, or that we can have on GitHub as standalone projects. There's the possibility to write blog posts. We're always happy about guest blog posts on the Flower blog itself, but there's also a lot of other blogging opportunities, obviously. Baselines is an initiative that just started and that is currently being developed. You can implement new strategies if there's a new paper coming out, and we've seen earlier how many new papers are coming out. Put it in a strategy and offer it to the community, and I'm sure it will be appreciated. Additional language SDKs and integrations are another great way to get started with contributing to Flower. And then obviously the last opportunity and probably the most difficult one is to contribute to the core framework itself. And with that, I'm happy to take some questions.
Thank you, Daniel. That was super exciting. I've got to say, I'm pumped for what's happening next. If you please ask some questions in the chat box here if you're attending via Zoom, and we can quickly attend to some of these. While we wait for one, I guess I would ask Daniel, say if I'm a PhD student out there, I'm looking for different frameworks to use. Why should I jump on Flower right now and implement my method inside Flower? What advantages would it give me over some other options I might want to use?
Yeah, I think once you want to build something that you want to actually put on an actual device, Flower offers a very nice story there. So it offers the flexibility to start on your developer machine, start out easily, and take an existing machine learning project, as I've mentioned earlier, take an existing project, just integrate a few lines of Flower code, and we'll share that in the code tutorial later on how to do it exactly. And then you can build a very simple system. It's super easy to get started. And then you can gradually evolve the system to become more complicated. So initially, you can start with the built-in strategies, and then eventually you can move to something more sophisticated, start to customize these, or start implementing new strategies from scratch.
I see, I see. I guess there might be some other type of users out there too. So what if I was I could be in doing some industrial research. I've some folks around me, or maybe I wrote a machine learning pipeline myself. But now my boss wants me to say, can you federate this, Nick? How easy would it be to go from the pipeline I have already to using Flower to federate it?
Yeah, it's a very good question, and we get that question a lot. Usually, if you build this pipeline yourself and you know this pipeline inside out, then it shouldn't take you, if it's not super sophisticated, it shouldn't take you more than 2 hours to federate that existing pipeline. And we've seen them before. People who just started out with Flower, they've never heard about Flower before, that they haven't seen it before, that they never built something with it before. They took an existing, for example, a Keras-based workload or a PyTorch-based workload, and they federated it within less than 2 hours.
Interesting. Yeah, that seemed pretty useful. We have our first sort of user question or participant question here. It says, do you see Flower being used in what they've termed cross-silo settings? So maybe you want to say, what do you think cross-silo, in your definition, what is a cross-silo setting? And then how well does Flower sit inside that setting?
Yeah, I would say cross-silo setting is often defined as a setting that basically consists of different data partitions, and these data partitions, they're being held by, for example, different organizations. And yes, definitely, I think Flower is a great way to build something that runs across these different silos. And the flexibility, I think especially the flexibility on the client side is an important factor in that, because these different silos, they might use a very different technological stack. So in Flower, in theory, you can implement one client and start that in each of these silos. But what you can also do, and that allows you great flexibility for integrating with these existing tech stacks, it allows you to build different clients and have all of these clients connect to a single server. So you could have one client implemented in Python, for example, accessing a, I don't know, Postgres database, but you could have another client in the same workload implemented in Java, accessing a Cassandra database, for example, and they could still collaborate on the learning as long as the model is the same and as long as the data format that you feed into the model is the same.
It seems really good for building also like POCs. If I want to build a proof of concept, perhaps I'm a systems researcher, I might have a couple of, I might have two organizations I want to analyze the situation. Maybe one's in TensorFlow, one's in PyTorch, and you're saying I can use Flower to build a federated system out of those two, very independent stacks without changing a single line of code inside them, right?
Absolutely, and that's something that is sometimes you can't get around that, because different organizations, they might enforce you to do things in a certain way. So you want to have a lot of flexibility when it comes to what happens inside of these organizations and what happens on these data partitions.
Okay, so I guess we could take two more questions so we don't run over too much. One question is quite a specific one. It is, how easy would it be to switch the Flower communication protocol from gRPC to something else? For example, MQTT or REST? How hard would it be to do that?
Great question. It's something I didn't cover in the talk, but I thought about covering it. Actually, it's not that difficult, and we will see in the scalability talk, we will see one approach on how to do that, and we have an example on how to do that in as an open pull request. So it's actually not that difficult. The entire server logic, strategies, and the server loop, the core server loop, they talk to something that we call a client proxy. And this client proxy is basically defined as what you would call an interface in other programming languages. So you can implement client proxies that use different communication protocols. You can implement a client proxy that uses gRPC under the hood. That's what the core framework does. But you could also have a REST client proxy or a MQTT client proxy, and then communicate using a different communication stack. And then on the client side, it works in a pretty similar way. You can basically do the opposite and have a switch out the entire communication protocol. And just to add to that, you can even have different communication protocols in the same workload. So you could have a subset of client connected to the server using gRPC, and then you have another subset of clients connected to the server using REST, for example.
I see. Yeah, makes sense. That's very good. So last question here is, what would be your thoughts on using FL strategies that incorporate non-neural network and machine learning techniques? You know, for example, somebody might have some of these scikit-learn things. They might have a decision tree, maybe some other, maybe an old SVM model. How could they? Is there some way to integrate them?
Well, the first question you would need to answer is whether this model is a model that you can train in a federated fashion at all.
Right.
Maybe it is, maybe it isn't. So that's something you need to take a look at first. If it isn't, if it's not straightforward to train it with something like federated averaging, then you would need to come up with your own way of aggregating these the results that you get from individual clients. And I think that that's a great opportunity for research actually to look into these and basically come up with new ways of doing things. Scikit-learn and other frameworks, basically the only capability that you need in a framework in order for it to be compatible with Flower is that you can extract the weights from a model, then basically serialize these weights, send them over the network, deserialize them, and basically inject them in an existing model instance again. And that's what we need in order to communicate these weights or these parameters over the network. And that's all you need to federate learn basically workloads in different kinds of frameworks.
Okay, cool. Well, I think we better close it there because we're blowing through our break time. So thank you again, Daniel. That was a great overview of where things are and where things are heading. So let's now take a short break for